Our next presenter is Dan Gullickson with the Minnesota DOT. Dan is a University of Minnesota forestry graduate with over 35 years of experience working with public and private landowners installing windbreaks, shelter belts, and snow fences to better manage blowing and drifting snow. Dan is the blowing snow controlled shared surfaces supervisor with the Minnesota Department of Transportation. Dan, the floor is yours.
Thank you, Jeremy. Thanks for this opportunity to present today and share MnDOT's experience with our snow fence program. And Kathy, can we take it to the next slide? You know, there's a human toll due to snow and ice related traffic crashes. Our traffic engineering office looked at crashes over the last 4 years, 2020 through 2024, and found 18% of all of our crashes were tied to snow and ice. 198 fatalities. These are, you know, life-changing, life-consequencing type events that can really affect families. And one of the opportunities that we've seen is where we've deployed our snow fencing, we have been able to see a reduction in crashes by 22% as compared to those areas that didn't have the benefit of those snow fences. So these snow fences have an opportunity to help with not only mobility, but also reducing crashes. Next slide. You know, one of the keys to a maturing snow fence program is knowing when and where to deploy snow fencing. And in MnDOT, we actually have a team of designers that this is their job, is to design blowing snow control treatments. And we look at existing blowing snow problems. We look at, you know, has the land use changed in these areas? You know, maybe there's going to be a new roundabout project that's going to create a future snow problem. You know, we get involved with our program delivery folks to look at upcoming projects and look at how we can prevent blowing snow problems after they're built. And then also, you know, finding available funding to help solve these problems. Next slide. So in Minnesota, along our MnDOT maintained roadways, we have about 737 living snow fences. These living snow fences, many of them were planted in the 1970s, maybe some of them even earlier, and they're still providing function for us. We have 223 structural snow fences, and our structural snow fencing is the flexible composite rail type system. Permarail is one of the manufacturers, and we also have another manufacturer named Magnum Ventures that make the structural snow fence for us. They come in 4, 6, 8, and 10-foot tall heights. We also still put up the seasonal snow fencing that's 4 foot tall, put it up in the fall, take it down in the spring, and then working with landowners and farmers to do standing corn rows. And standing corn rows is our gateway to work with a farmer landowner to see, you know, the benefits of the blowing snow. And it's our gateway to introducing them to maybe a future living snow fence or structural snow fence that ends up being a longer term commitment. Next slide. MnDOT has been inventorying our snow problem areas. We call them snow traps since 2001. And we've got about 4,529 snow traps covering about 2,179 centerline miles of roadway. And so seeing the drifting on the road is one thing, but blow ice is a little more difficult to explain. So let's go to the next slide. And why don't we hit play? So blow ice is one of these phenomena that happens after a snow and ice event. You can get a wind speeds of about 20 to 30 miles an hour like we see here, and that will pick up those snow particles and start moving them across the road, icing it up. This is on Highway 14, US Highway 14. It's an east-west roadway. The road profile is about 3 feet higher than the farm fields. And so the wind is actually working in our favor here, just keeping that snow moving across the road, but it is icing up the road. As we start to see to the left here, we're going to introduce on a curve a living snow fence and structural snow fence system. Our road profile is going up. We're going up onto a bridge. And this allows us to introduce the snow fencing within the highway right-of-way because the road profile is elevated. As long as the snow fence is 4 feet below the height of the road profile, the wind will work in our favor, and then the snow fence will catch that snow and helping to improve our driving condition. And back in 2011, our traffic safety office said, you know, Dan, if you want to reduce crashes, focus on the curves, which is what we're doing right here. Next slide. To be able to understand if we have a maturing snow fence program, we have to understand the past. And, you know, unfortunately, we don't have any MnDOT employees that worked back in the 1930s and the 1940s here that I can talk to about what they did back then. But looking at the Minneapolis Star Tribune, Star Journal magazine, they had an article in there, and back in 1942, MnDOT was spending $1 million on snow and ice. Of that $1 million, $180,000 was spent putting up this slat style snow fencing. And it was about 1,000 miles that they put up each year. And that accounted to about 18% of their snow and ice budget. Today, our snow and ice budget last winter was about $121 million, and we spent about $4 million in the design, installation, and maintenance of our snow fences. Next slide. So with the 4-foot tall snow fencing, it has the capability of holding about 5 tons of blowing snow. And we have areas of western and southern Minnesota that are more open, that have almost unlimited fetch distances. There we get anywhere from 10 to 20 tons of snow. And those 4-foot tall fences aren't tall enough. And that's where we start to introduce the taller fences, the 8 and the 10-foot tall ones, to contain that amount of snow. And so taller fences do make a difference. Next slide. You know, back in the 1960s and early 70s, mechanical snow removal became more popular, and, you know, trying to use brute force to open up our roadways. We know that this equipment can't be everywhere at once. And also, you know, having closed roadways is very, you know, damaging for freight and commerce and the like. And so what we've been looking at is where to deploy snow fencing in areas where we have to go in there with this heavy equipment to reduce the need to do that. Next slide. A teaspoon of salt has the capability of polluting 5 gallons of water. That's from our Minnesota Pollution Control Agency. And we have found where we've deployed our snow fencing, this is along Interstate 94 east of Moorhead, that we were able to reduce our chloride or salt use by 40%. And that is a huge savings in terms of helping reduce water contamination and being more efficient with our salt. Next slide. In 1991, Ron Tabler, who you've heard before, he reintroduced MnDOT on the science of passive blowing snow control. And in 1991, he came to Minnesota. I had the opportunity to be there for that conference. And we really were connecting our maintenance office and our design community to work together. Because Ron Tabler said, you know, blowing snow isn't just a maintenance problem that you have to plow your way out. There's things that we can do in design in terms of, you know, widening the ditches, raising the road profile, adding snow fencing. These are things that can work in harmony and help our snow and ice fleet be more efficient. Next slide. And so with Ron's help and also with funding through MnDOT research, we were able to, this is a one-stop shop, snowcontroltools.umn.edu. That Snow Control Tools website is our one-stop shop that we go to get our design, our winter climate data that we use in our snow fence design. We also have cost benefit, a tool there to see if the fence is cost effective to pursue. There's also previous research projects that are linked there. This is really a good resource for you to use to learn about blowing snow control. Next slide. And one of the things that, you know, location when it comes to design. And in our state, we've got 3 locations that are Siberia-like in their condition in terms of the amount of snow that gets relocated by the wind. And these are areas that we realize that, you know, with this tool, we can really look at the location for determining what the appropriate fence offset should be from the road. It's looking at climate data from 370 observation sites across the state and using Dr. Tabler's algorithms to help us be able to interactively design. Next slide. But one of the things that we're moving towards is going from the two-dimensional world to the 3D world. And in the 2D world, it's looking at everything in terms, as we see in the image on the left there, is flat topography. And we can see these snowdrift profiles based on fence porosity, but you're not seeing a ditch. You're not seeing the undulation in the topography. And so the image on the right with the 3D looks at what is the road profile? What is the height of it? What's the ditch depth and width? And start to visualize what that snowdrift will look like on the landscape. Next slide. And so we are currently working with Civil Solutions, an engineering firm out of Chicago, Illinois. And Civil Solutions is working with us to develop a 3D snowdrift simulation that would incorporate the design of the snow fence, looking at the undulations in the topography, and draw what that snowdrift would look like, which will be a really good communication piece for landowner engagement, as well as working with our maintenance community. Next slide. And so as MnDOT looks to the future, we're taking more of a corridor approach to blowing snow control. That's going to create a more consistent driving experience for the motoring public. Next slide. And so as we look at this corridor approach, we're looking at, what's the frequency of road closures, what's the crash data to help guide where we should prioritize our efforts, because we got like 5,000 snow traps out there. Where do we begin? Next slide. We also look at the labor, material, and equipment costs that are being tracked in terms of what's happening, what's being spent on those plow routes. Next slide. And then, we are managing the wind is what we're managing. And with the Maintenance Decision Support System, the MDSS, looking at the frequency and the vulnerability for where wind is a problem. And, as we get into the western part of the state, we're looking at upwards of almost 800 to 900 hours where the wind is moving that snow around. And that helps us see, where the greatest need is for snow fencing. Next slide. And so utilizing this concept, we're able to start to see which corridors in a MnDOT maintenance district would show up as being the most important ones to address. And this would be the I-94 corridor in this case. This is the areas that were showing up in red. This scoping tool really helped us to be successful in getting a federal Protect grant to get federal funding to help with the mobility and the transportation of this very important corridor. And we found with this Protect grant, we had a benefit cost ratio of for every dollar spent, there was going to be a $3 return. Next slide. In terms of an evolving snow fence program, we're looking at, we have 2 snow fence manufacturers that are on our approved products list, and that link is located on the bottom of the slide there. And that's Magnum Ventures and Permarail. And we're also evolving to using either a concrete sleeve or a concreteless sleeve, like you see on the right, which we don't need to use concrete, which speeds up the installation process because you don't have to let the concrete cure before you tighten the rails. Next slide. We're also, if you look at the slide on the left, the rails really are on the one side of the fence and the posts really stick out visually. And so in 2017, after working with our landscape architects, they really felt that if you wanted to improve the appearance of the snow fence, weave the rails. And so whether you're on the right or the left side of the fence, you have that uniform looking experience. And in talking with our manufacturers, they feel it actually probably makes the fence a little more sturdy to the wind loads out there. And so we are now weaving our snow fences. Next slide. We're also making an effort to get every one of our snow fences in the transportation asset management system, tracking where these assets are occurring, because Dr. Tabler used to say the problem is lost with the solution. And so knowing where we have our snow fences will help with the transition as our workforce transitions, understand why they're out there. Next slide. Good fences make good neighbors, making sure that we keep our rails tensioned properly so they're not sagging. Mowing around the perimeter of our snow fences with establishment really helps control weeds and helps get more sunlight to the living snow fence to help them grow faster. Next slide. And then we are now, because a lot of our snow fences are starting to get to be 20 years old that are living, going in and rejuvenating them through coppice pruning. By doing that, it will take out the dead wood. Next slide. And the image on the left shows where we coppice pruned adjacent to where all the wood chip is. And then you can see the regrowth on the right there that has emerged. And then after about 3 years, we'll go back and we'll coppice prune the other side. And when you coppice prune, you have an established root system, and you can get about 3 to 4 foot of new growth as a result of this. So it's a good way of sustaining your snow fences long term. Next slide. And so as we track our snow fences, we spent about $370,000 on snow fence maintenance over the past year. And that would be the coppice pruning and the tensioning and tightening of our snow fences and mowing. Next slide. Looking for value added with our snow fences. North Dakota State University, we've partnered with them with a research project. You can see the link there for where to learn more about the research. And what they did was they constructed a 100-foot solar snow fence, which is silver in color here with the solar panels, adjacent to one of our flexible composite rail snow fences. Next slide. And what we found with that 100-foot section is that it was generating about 11 kilowatt hours of energy per day throughout the year. The snow fence is oriented east to west, and the panels are on the south side of the posts. And so it was generating 11 kilowatt hours per day. And if you wanted to meet the needs of a typical household, it's about 30 kilowatt hours per day. Next slide. And so with this test project, we did not incorporate the energy into the grid. We utilized it on site. We put it into the shed, and in that shed, there were these batteries with the inverter and the controller. Next slide. And then we used that energy to power the webcam out there with the weather instrumentation. But also, if you look at the image on the left, it was after a snowfall, and the image on the right, it shows the heating pads there having melted the snow. So it was really an active snow fence that also melted snow as well as catching snow. Next slide. So as we look to the future, look for value added. Maybe it is putting the snow catch area, planting it into pollinator habitat like we heard for bees and monarchs and grassland nesting birds. Next slide. Maybe it's to help reduce wind erosion, keeping that topsoil on the farm field and not in the ditches. Next slide. Or maybe it's for the beauty. That might be the reason for someone to want to entertain doing this. And in closing here, next slide. A maturing snow fence program is good fences make good neighbors. Build those partnerships, use data to identify where to deploy snow fencing, secure funding to grow an effective snow fence program. Look for opportunities to diversify income for landowners for snow storage, and then get that habitat, energy, and added value. And as Rick Nelson said from talking in winter ops, the best snowflake is the one that never lands on the highway. Thank you.